Okay, welcome back to second session. Okay, now let us discuss these another examples of user defined functions. Like for example, if I want to compute, let me share the slides. Now let us discuss these another examples of user defined functions. Like for example, is Jupyter notebook is visible to all?
Yes, sir.
Okay, so in this basic sigmoid function is shown here. So suppose if you want to calculate the sigmoid, so all of you know the formula of sigmoid, that s is equal to 1 upon 1 plus e raised to minus x. That is the formula of sigmoid. And for exponential function we will be using some module from the math. So we have a modules called math module where all mathematical formulas are available. And inside that this exponential function is available. So this actually function is example of inbuilt function which is available inside the math module. And this basic sigmoid module is basically a function which we are defining as per our requirement. So it will compute this formula 1 upon 1 plus e raised to minus x, and it will return the answer s to us. So let us execute this function. We want to find out the sigmoid of minus 10, then it will give us the result in this way. Suppose if you want to find out sigmoid of 0, then it will give us a 0.5, right? Because e raised to 0 means it is a 1, so 1 upon 1 plus 1, that is a 0.5. If you want to compute sigmoid of 1, it will be a 0.73. If you want to calculate the sigmoid of minus 1, it will be a 0.2689. So like this sigmoid value you can compute with help of a sigmoid function. So this is the name what we are giving, basic underscore sigmoid. Whatever name you want to give, you can give it, except keyword and standard words which are used in Python, you can use any other name. So there is a very popular NumPy module, that is a numerical Python module available in a Python, which has a lot of inbuilt function. Like if you want to create some matrices and you want to do matrices operation like addition, multiplication, finding inverse of matrices and so many other functions, then you will be able to define the matrices with help of a this NumPy module. So import NumPy as NP. So now here we are giving this namespace NP to this NumPy module. So later on we will call all the functions with help of a NP. So this NP will represents all the functions available inside the NumPy Python module. So let's say we want to call array function which is available in this module, then we can write np.array, and then inside this it is basically creating, let me execute this, print a. So as you know, that is 3 by 3 matrices. So this 1 2 3 is our first row, this is second row, and this is third row. So every row is written in a square bracket, and after every row we put like this we will be able to change the different rows in this way. Then suppose if you do not want to create a 3 by 3 matrices, you want to create only one row, then you can write in this way np.array and 1 2 3. So let me print this b. It's already there, I think, like this. Later on you can also change the elements of these matrices. Then you can also display the size of both. Let's say np.size a. So it will represent 9, because it is 3 by 3, so 3 by 3 is a 9. Similarly I can display size of b, it's a 3. NumPy module is very useful. It will also be able to generate the random numbers. If you want to generate random numbers, then NumPy module will be useful. During our last session, we generated random noise and added it to the sine wave using the random numbers. So in this case, A is equal to np dot random dot random. This is RANDN is the random function which is available inside this module, and 3 by 3. So it will create a matrices of random numbers having a 3 rows and 3 columns. You can also generate 3 rows and 1 column. So depending on the size requirement, you can do it. Then you can also do the multiplication. So C is equal to A into B. That is basically a matrix multiplication of A and B. So whatever numbers we are generating, we are adding it, and after we are multiplying it, and after multiplication we display the multiplication values. So this is our first matrix A, this is column matrix B, and multiplication of these two results into a C. So all three you can do it. So NumPy is very much useful. We will be frequently using this NumPy. As all of you know that we normally declare pi, but here you can pi is available directly. Let me call it an np.pi. So it will display the value of pi there directly. So pi is available there. If I write here in this way dir np, then these are the list of functions which are available in the NumPy. So you can say very large list you will be getting here. So these are the functions available with the NumPy module. So many functions are already given in that. Then there is a very important module is called pandas. Pandas is basically useful for statistical calculations. So you can import pandas as PD. So now PD namespace we have given. So this PD you can use to read some CSV file that is created by either Excel or by something. So this DF is the data. So I have given some name here of that data set. So it will be stored in this data set DF. You can give any name here. So it will read the CSV file. For example, I have a Microsoft Team student data IC department. Then I have exported your grades because you have submitted your quiz in a Microsoft Team, and I have exported that into CSV file, and later on I want to check this file. I check directly in Excel, but I want some statistical calculations, then I can import it here using the pandas. So let me run this. It will show me df.head, that means it will show what are the fields available in that. df.shape means how many fields are there. 76 rows are there and 6 columns are there. So your name, your email addresses, and whatever the program points you have achieved, that all will be displayed here. Then whenever I will write df.describe, it will give me the description, that how many values are there. Let's say it was the quiz was taken on 13th July. So out of 76 students, 54 appeared for it. Then maximum point were 5, but the mean value of all the points, if I calculate for all the students, it is a 3. The standard deviation is 1. The minimum points achieved in that quiz was 1. Then this is a percentile, 25 percentile. That means 25% of the total students got 2 points. Right? So it's basically a percentile. This is a 3, and 75 percentile means top 25 students got actually 4 points in everywhere, and maximum point was 4. So this is actually how you will use describe function. So describe function will give all the statistical data available in that CSV file. Let me read one more file. That was your quiz 2. That quiz 2 I store in a different data frame, df1. Previously was a df, now I am calling it as a df1. It's different. So whenever write, let me run this first. Let me write df1 describe. Then it will give me all this description like marks and points, So count is here 76 is the number, total number of students are 76. Out of 76, 52 appeared for the quiz. Remaining is still not appeared for the quiz. The manual value of point is a 3.86. Standard deviation is 1.15. Minimum point achieved is a 1. A maximum point achieved is a 5. Then total 25 percentage of students have a 0.3. Then that means those who have achieved 0.5 score, they are from 75 percentage to 100 percentage. So total 25 percentage of total students got the 5 point. So this is the statistics we are getting. You can also use one more module called Seaborn module. It's a very useful module. So I am importing Seaborn as an SNS. So this is actually very useful to plot the statistical data basically. So I am using one function, inbuilt function called count plot from this Seaborn module. So I am calling that function by sns.countplot. X is equal to marks, that on the x-axis I want marks, and I want to count all the marks values, and I want to use this database df1. So when I will run this, I will be getting a plot. So what it will do, it will calculate the different value of marks. It will perform the counting, and then after performing the counting, it will plot it there. So now you will get the plot here, that there are these are the students, number of students actually got 5 points. These are the number of students got 4 points, 3 points, 2 points and 1 point. So as you can see here, about 19 students got 5 points. That's why about 25 percentage is having a 5 points. Then as you can see here, about 14 students got 4 marks out of 5. So like this, it will plot a graph. And if you use this head function, df1.head, actually it will give all the headings: first name, last name, email address, marks. That means total marks achieved by the students. This NaN means still not appeared for the quiz. Points is a 5, and then some feedback I have given, so that feedback will be also displayed here. Then if I print this data, then entire data set will be printed here. Then if I use this function df1.info, then it will give me the information of this particular data set, that what this data set is. This data set has 76 entries because there are 76 participants are there, team members are there in this Python programming group. The index value given is 0 to 75. Then there are columns called first name, last name, email address, marks, points and some feedback. The data types are also given here. What are the different data types available in this particular data set? So this Panda is very much useful for all database applications. Apart from that, there are many other functions available in the Panda. Now let us define something called user defined functions. I will call you. So what I will do, I will start the Python IDE and then I will show it there only. So now suppose if you have a different custom functions which you have written, we call it as a user defined function. Then you can write your own function in some file, and then you can use all these functions in some other program. So for example, I will show you here. I have written few functions. One is a very simple function called define add. So it will do the addition job. Of course, in Python itself, this function is also available, but just to show you, I am displaying it here. So what does it do is, it just accept the 3 arguments and perform the summation of all these 3 and just return the addition of these 3 values. One more function is return define sine wave. So what it does is that it will accept the a frequency of sine wave and number of sample point, and then calculate the sine wave and then return that sine wave to the main program. One more function is written here is a DSBSC, that is a double sideband splash carrier function, which accepts the carrier frequency, the message frequency and number of sample points. It will compute the DSBSC waveform. All of you know that it is nothing but a multiplication of carrier and message frequency. So both the signals are multiplied together and it will generate the DSBSC waveform, and it will just return the signal back to the main program. One more function written is a defined amplitude modulation. So it is AM. In that it accepts the different parameters like carrier frequency, message frequency, then one more parameter called modulation depth, which will define the modulation index, as well as number of sample points. Then this is actually formula for amplitude modulation. All of you know that it has a carrier plus 2 sidebands. So this is the same. This is a carrier component and then these 2 sideband components. So the same formula which you have already studied in communication engineering, the same formula is written here. So these are the functions defined in this Python file called myfunctions.py. So if I want to use this file, then I have to call that in my main program. So I am calling it in this way: import my functions as MF. Just like we were importing numpy as NP, but numpy was module available from Python itself, or is created by somebody else. But this my functions is created by ourselves, and all our functions, whatever we want to use, we want to store it in this particular myfunctions.py file. And as and when these functions are required, we can just call these functions here. Right. So this is actually a collection of all user-defined function. Then import matplotlib.py plot as PLT. So this is actually for plotting the waveforms, but this is actually a standard which is available inside the module called matplotlib module. This is not written by us, but whatever functions are available in the my functions is written by us. Then a equal to 10, b equal to 20, c equal to 30. Just for an example, we are taking 3 variables. We are passing this 3 variable to add function. So add function is basically a part of our my functions, and my function we are using as a name as mf. So I will write s equal to mf dot add a comma b comma c. So it will perform addition of a, b, c, and it will return the result to the variable s, and then we print the variable s here, print s. Screen, both the screens are visible. Program, this main program as well as this the function file, both are visible to you, or is there any problem? Now I have only 5 minutes, because after 5 minutes my laptop will battery will be over, and then after I will stop my lecture, because there is no electricity. So I am running fortunately I have some charge in my laptop, but I think within 5 minutes it will discharge. So I will just continue this lecture, and meanwhile, if time permits, we will have an instruction. So s is equal to mf dot add. I am calling this add function. Then I am calling this signal function. So in a signal function, what I am doing, mf dot sine wave in 3 into 1024. That means I am specifying 3 cycles here of sine wave. 1024 is the a sample points. Then I am plotting this sine wave, and then I am giving some x label and y label. Then I am calling the DSBSC waveform. I am passing 100 cycles for carrier, 2 cycles for a message. 1024 is the sample points. Again, I am plotting the DSBSC waveform. I am calling the function mf.am. am is also written here, as you can see here, am into bracket c comma n comma m comma n. So 4 argument I have to pass. The first argument 100 is actually a number of cycles for a carrier, message cycles. 0.5 is a modulation index, 1024 is a sample points. And again I am plotting the same with giving some name of all these x-axis, y-axis and the title of the plot. So let me run this program. When we will run this program, it will give us some output. So initially it gives 60. 60, that means it has printed S. S is 60 because in addition what it does, 10 plus 20 plus 30. So addition is 60, so 60 is displayed here. Once that operation is over, it displays the sine wave. As you can see, 3 cycles are there. So you can see the full 3 cycle of sine wave is visible here. So we are calling this function. This function is written in our function file and we are importing that function file. Name of that function file is my functions and we are importing it as a mf. And we are calling all the functions stored in this my functions file by giving a name like mf.sine-wave. So it is we are calling this function. When we close this figure, another figure will be displayed. So another figure is nothing but a dsbsc. So we are calling one more functions from the my functions file, that is dsbsc, right? So mf.dsbsc into carrier cycles and 2 message cycles will be there. DSBSC waveform will be computed and then finally it will be plotted with help of a plot function. When we close this figure, the third amplitude modulation waveform, we are passing all these arguments again. As we can see here, modulation depth is a 0.5, so here also we are getting a modulation depth 0.5. If you change the modulation depth here in the function argument, the modulation depth will also change here in this way. So I will upload this program into our Microsoft team so that you can download it and execute in your own PC and laptop. Maybe soon my laptop will discharge, so I will start the instruction section now and